Okay, so here's our next wacky function. So we have let's see, so we're going to go up at 45 degrees. So we have a ramp that goes up, and we don't have any leveling off time, and at time equal to 2 seconds, we bring it back down to 0, and it's over. Let's build this one. Okay, so the first thing we want to do is we want to break this up into parts that we can handle. And that's what this is. So we have a ramp starting at time equal to 0. At time equal to 2, I have 2 ramps coming down. The first ramp that comes down levels this one off, so it cancels it. Then the second ramp brings us down. And then at time equal to 4, I have another ramp take off, and that levels the whole thing off. Okay? And I can write that answer fairly directly. So here's a ramp coming up with slope of 1. At time equal to 2, I have 2 ramps coming down. And at time equal to 4, I have 1 ramp going up. And that's the end of the response. We're there. All right. I have one more that's kind of involved. So we're ready to take on something a little more complex. And here's this one. So what does this consist of? It consists of a step input at 0. And then keep in mind, that goes on forever. At time equal to 1, a ramp comes in for whatever reason. Okay, at time equal to 3, the ramp is leveled off and it starts dropping like a parabola. Okay, and so here's where this parabola starts. And then at time equal to 5, out here, we undo the effect of the parabola and have a step of 1, 1, 2, 3 up. And our final value is at 2. So we've got all sorts of things happening. If you can do this, by the way, you can do anything. All right. So we have to build this thing up. And so let's just go to that picture. So we're going to start with a step. And that's level, so we can work off of that. We don't need to, this ramp starts from where that is. So we can have a ramp, which will start from 0 that adds on to this here. At time equal to 1, here's the ramp happens. Okay. At time equal to 3, we want to stop the ramp, so we send a ramp going with the opposite slope going here at time equal to 3. And then we delay out a parabola, minus t squared dropping. Okay? Now, what happens next? We're going to hit 5. We want to step up by 3, so that's easy. But we have to have something that undoes that parabola so that we can go from where we are and go up 3. And that's this function. It's like a parabola, but here's the thing. This parabola, over 2 seconds, it drops 1, 2, 3, 4 units. So we want it to drop 4 units. And I need a parabola here, but I can't let a parabola start from 0 here because this thing is, with t squared, it's way, way, way ahead. So I need a parabola where I'm going to jump it ahead by 2 seconds. Okay. And then subtract off 4 to allow it to lose the 4 that it's at. Okay, so picture starting at 0, t plus 2 squared minus 4, going up. That will undo this thing, and then I just have to delay it by 5 seconds. So see what we have here. This is t plus 2, so and this all starts at time equals 0. So when you're looking at time, 5 here is irrelevant. This is a signal that would normally start at 0, being pushed back by 5 seconds. So the time doesn't matter. This thing had a 2-second head start. I'm giving it whatever t equals 0, starting from 0, but I'm giving it a 2-second head start. And I'm allowing it to go undo what it's doing by 4. Okay, this will allow me to maintain this piece. Okay? So, and if you're not buying into this, check out the math. This will work. All right. So, here's what we have. I have a step input starting. I have a ramp at time equal to 1, e to the minus 1s. At time equal to 3, I have a ramp coming down. At time equal to 3, here's a parabola. T squared is 2 over s squared. All right, so there's that. At time equal to 5, I need a step of 3. And then at time equal to 5, I also need this sort of abbreviated parabola where I accelerate it and take something off of it. Okay, because I want it to start lower. I have to take 4 units off to make that happen. And so this is that. So if you multiply it out, that's t squared plus 4t. So t squared is just 2 over s cubed plus 4t. A ramp is 1 over s squared multiplied by 4. And there is our signal. And here are all the parts we used. Didn't really use an impulse, that would be a 1. Laplace transform with a step, 1 over s. Integrate a step, you get a ramp, 1 over s squared. And if you integrate t, you get t squared over 2, which is 1 over s cubed. But I needed t squared, not t squared over 2, so I have to multiply that by 2. And that's where everything comes from. And so with that, I'll leave you to think about this, though perhaps I'll make one other comment. This signal, you're envisioning it starting at time equal to 0. And then I delay it out to here. So your time base is based on 0. All right, so when we multiply this out, notice you get t squared plus 4t. What is this thing? At time equal, I accelerated this thing. And if I did, and I subtracted off 4 because the 4 that it lost, I wanted to keep off. So notice that at time equal to 0, which is being blasted out to 5, I put a t, if t equals 0, this thing is at 0. So I want it to stay here and start moving up from here. Okay, I want it to undo this parabola. As this parabola goes down here, I want this thing to go up and undo it. Okay, so its value when it starts has to start from 0. If I had t plus 2 squared, that would be t squared plus 4t plus 4. It would bounce it up an extra 4. That's why that's there. It starts from 0. I accelerate it, but I make sure it starts from 0 so that I level it off at this point. Anyway, that's what this problem is. I'll leave you to think about that a bit. And the next step, we have 2 more parts that we have to do before we move into our modeling. So the next big part we're going to look at is frequency response. And that basically says, how does a system respond if you put if you put a sinusoidal input in. Sinusoid in, you'll get a sinusoid out. We're going to spend some time looking at that. After we've done with that, we're going to do a little bit of control theory with block diagrams and show some things with that. And then we'll start modeling. So that's where we are. I'll catch you next time.